Lost your phone? Yeah, that's fun. I know how that feels. Trust me. I know exactly how that feels.
No, you didn't lose it. You got stolen.
Yeah.
Few words.
I hope there are several hundred really super awesome people who care about you, because that's a good feeling. Okay. Oh, okay, good. All right. So here, does it make sense? Oh, sorry. Does it make sense to you that the total resistance is just going to be RA plus RB, right? And so, actually, you know what? We don't even need to, yeah. So then that means there's going to be a given, well, actually, does it make sense to you that IA is equal to IB? The current through A has to equal the current through B. It is super important that that makes sense to you. If it doesn't, you need to say something. Okay, so imagine a resistor is just like a turnstile at Knott's. Right, you want to get on the ride, click, you got to use a little bit of energy. So this is a hallway with two resistors. And then this one is a little harder to push than this one. But does it make sense to you that if 10 people enter this hallway, 10 people have to go through both resistors, both turnstiles? Okay, if that's true, then what I just do is I say, well, how does PA compare to PB? Well, what equation should I use? We know that power, that there are three equations. What's the base one? This one's on your formula sheet for sure. P equals IV. But remember, there's also V squared over R and I squared R. Right? Well, what do we know about the currents? They're both the same. So what we get is PA is equal to I squared RA, and PB is I squared RB. And I just called it I because we know they're both the same. So this cancels. And so what do you get? The power through B, the power that B is using up